Hi dear students, this particular class I want to do some applications on monotonicity and maximum minimum, especially how to draw the graphs, at the same time applications regarding the roots of the cubic polynomial, and one more thing what we are going to discuss is how to check whether it is a one function or onto function. Those things we are going to discuss. So this is the first question. The first question is given as f of x is equals to 2x cube minus 15x square plus 36x plus 6. So we have to draw the graph for this function. So find out f dash of x. F dash of x is equals to 6x square minus 30x plus 36. That is f dash of x. Now if you take 6 common, we will get x square minus 5x plus 6, that is equals to 6 into x minus 2 into x minus 3. Now this is number line. We have 2, next 3, plus, minus, plus. So with the help of this information we can say from minus infinity to 2 union 3 to infinity. In this interval from minus infinity to 2, 3 to infinity, f dash of x is positive, so the function is increasing function in this interval. At the same time you can observe between 2 comma 3, f dash of x is negative, therefore the function is a decreasing function. That is the first information we got. Where the function is increasing, where the function is decreasing, that information we have. And the second information you can see, according to the first derivative test for local maxima and local minima, as x values are increasing through 2, f dash of x changes its sign from positive to negative. So positive to negative means what we can say, at x is equals to 2, at x is equals to 2, f has local maxima. Therefore that local maximum value is equals to f of 2. X is equals to 2, we have to substitute there. Just that part I already simplified here. F of 2 value we got 34. X is equals to 2, substitute here, you will get the value as 34. At the same time you can check, as x values are increasing through 3, f dash of x changes its sign from negative to positive. Negative to positive means we have a local minimum. That's why at x is equal to 3, the function has local minimum. Therefore, that local minimum value is equals to f of 3 is the local minimum value. So f of 3 also, that means x is equal to 3, substitute here. That value also I simplified and I got 33. So that is the informations what we got. Function has a local maxima at x is equals to 2 and that local maximum value is 34. Function has a local minima, that is at 3, that local minimum value is equal to 33. Whether you observed or not, local maxima also positive, local minima also positive. At the same time, between 2 comma 3, the function is a decreasing function. Between minus infinity to 2 union 3 to infinity, the function is an increasing function. So with the help of this information, I am going to draw the graph for this function. Observe here, this is let us say this is 2 here and we have 3, right? So we have the information at x is equals to 2, the function has a local maxima, that local maximum value is equals to 34. Let us say this is 2 comma 34. At x is equal to 3, the function has a local minima, that minimum value is equals to 33. That's why somewhere here we have 3 comma 33. This point is 3 comma 33 and this point is 2 comma 34. We have a local maximum. But the information is saying that from minus infinity to 2, from minus infinity to 2, the function is strictly increasing function. But now here we have to consider what is f of 0 value. At x is equal to 0, what about the functional value? F of 0, you can observe we are getting f of 0 is equal to 6. That means the graph cuts the y-axis at 0, 6. So that's why based on that information we are discussing the problem. This is maxima. You can see from minus infinity to 2 the function is increasing function only. At the same time between 2, 3 the function is a decreasing function. Between 2, 3 the function is a decreasing function. Again from 3 onwards it is an increasing function. That is the graph of that particular function we got. But you can observe here the graph is intersecting x-axis at only one point. The graph is intersecting x-axis at only one point. So from this information we can say 2x cube minus 15x square plus 36x plus 6 is equal to 0 has only one real root. That root also a negative root. Right? At the same time this function is not a strictly increasing function. The reason is from minus infinity to it is increasing function. Again from 2 to 3 it is a decreasing function. Again from 3 onwards it is an increasing function. So it is neither strictly increasing nor strictly decreasing function. So it is not a 1-1 function. You can observe the graph is approaching from minus infinity to plus infinity. It is taking all the values. That's why if the function is defined from real numbers to real numbers, from minus infinity to plus infinity, it is taking all the values. So it is an onto function, but it is not a 1-1 function. Why it is not a 1-1 function? You can see here, between here we are drawing an horizontal line. You know, for 1-1 function, when it is not a increasing function strictly, when it is not a decreasing function, we can say it is not a 1-1 function. At the same time, with the help of horizontal line test also, if we are drawing a horizontal line here, that horizontal line cuts the graph at more than one point. That is the reason it is not a 1-1 function, right? So that is the graph of the function. With the help of the graph, we can discuss the few points, right? So next question we are going to discuss. The next question is given like this: f of x is equals to x cube minus 3x minus 30. That is the function f of x. Okay, right? We have to draw the graph for this function. Find out f dash of x. F dash of x is equals to, what about its differentiation? 3x square minus 3. Now if you take 3 common, you will get x minus 1 into x plus 1. Come on, number line. So wavy curve minus 1 and this is a plus 1 plus minus plus. Right? So the information is saying that from minus infinity to minus 1 and again from 1 to infinity, you can observe f dash of x is greater than 0. 1 to infinity positive, minus infinity to minus 1 also positive. So we can say function is increasing function in this interval. At the same time you can check between minus 1 comma plus 1. Between minus 1 to 1, f dash of x is negative. So we can say the function is a decreasing function. That is the first information we got. We know where the function is increasing and where the function is decreasing. That information we have. The next second point is at x is equals to minus 1. At x is equals to minus 1, f dash of x changes its sign from positive to negative. So at x is equals to minus 1, function has local maximum value, and that local maximum value is nothing but f of minus 1. So for the convenience purpose, I did the value of f of minus 1. F of minus 1 is equals to minus 28. Nothing. X is equal to minus 1. Substitute here. We will get f of minus 1. Next, at the same time, at x is equals to 1, f dash of x changes from negative to positive. As x values are increasing through 1, f dash of x changes its sign from negative to positive. So x is equals to 1 is a point of local minimum. Therefore, that local minimum value is equals to f of 1. So that f of 1 also x is equals to 1, substitute here, you will get f of 1 is equals to minus 32. That is the information we got. With the help of this information, we are going to draw the graph for this function. Between minus 1 to 1, it is a decreasing function. Less than minus 1 and more than 1, the function is an increasing function. At minus 1, we have a local maxima negative. At 1 also, we have a local minima negative. Whether you observed or not, either local maxima value or local minima value, both are negative only, right? So now the graph we are discussing here. So this is minus 1 and here we have 1. So at x is equals to minus 1, we got minus 28. So somewhere here we can say minus 1 comma minus 28. Minus 1 comma minus 28. Local maxima. At 1 we got minus 32. At 1 we got minus 32. Let us say this one as 1 comma minus 32. Local minima at 1. And observe there, f of 0 we are getting minus 30. F of 0 is equals to, somewhere here we are getting 0 comma 30. So what the information we have, from minus infinity to minus 1, it is an increasing function. From minus infinity to minus 1, the function is an increasing function. Again from minus 1 to plus 1, it is a decreasing function. Again from 1 to infinity, the function is an increasing function. That is the graph of that particular function, right? So we got the graph of f of x is equal to x cube minus 3x minus 30. At minus 1 we have a local maxima minus 28. At 1 we have a local minima, that is equals to minus 32, right? So that is the graph of the function. At the same time, whether you observed or not, this graph is intersecting the x-axis at only one point. That's why there is only one real root. That root also positive root only, because the graph intersecting the x-axis, positive side of the x-axis. That's why it has only one positive real root, right? So the next question is given in this way. F of x is equals to x cube minus 12x plus lambda, that is f of x, has three distinct real roots. It has three different real roots. All the roots are distinct. Whether you observed or not, in earlier cases, the graph is intersecting the x-axis at only one point. Local maxima, local minima, both are above the x-axis in the first question. In the second question, local maxima, local minima, both are below the x-axis, both are negative. Now that is the reason we got only one root, real root. But he is saying the equation has three distinct real roots. Then he is asking the values of lambda values we have to find out. Okay, three distinct real roots. That means definitely the graph has to cut the axis at three different points, right? Find out f dash of x. F dash of x is equals to 3x square minus 12, that is equals to 3 into x minus 2 into x plus 2. Now number line, this is equals to minus 2 and 2 plus minus plus, right? So from minus infinity to minus 2, and again from 2 to infinity, no doubt the function is increasing function. At the same time, between minus 2 comma 2, the function is an increasing function. That is the information. At x is equals to minus 2, we have a local maxima, because he is asking about distinct real roots, no doubt. At x is equals to minus 2, we have a local maximum value, because f dash of x changes its sign from positive to negative. At x is equal to minus 2, we have a local maximum. That local maximum value is equal to f of minus 2. At the same time, at x is equals to 2, we have a local minima, right? That local minimum value is equals to f of 2, right? So based on this information, now we are going to draw the graph of the function. this is minus 2 and here we have plus 2. So what the information is saying, we have to get 3 different roots. So that's why definitely local maxima we are getting positive means local minima we have to get negative. Again this one, the graph may be like this. We can't say exactly like this because f of 0 we don't know whether it is positive or negative. That depends on lambda value. So that's why graph definitely may be like this. The reason is here intersecting x-axis at one point, here also intersecting x-axis, here also intersecting x-axis. That's why it has 3 different roots we can say. Under what case? At x is equal to minus 2 we have a local maxima. At x is equals to 2 we have a local minima. That information we have. In a local maximum value, here we have a local minimum value. If these 2 values are of opposite sign, local maxima we are getting positive, local minima we are getting negative. Suppose you see local maxima we are getting positive, local minima also we are getting positive, then there is only one real root, right? So the graph is not like this. Definitely the graph will be like this. Local maxima we are getting positive means local minima we have to get negative, right? So that's why local maxima is nothing but f of minus 2. A local minima is nothing but f of 2. These 2 multiplication must be less than 0. F of minus 2 into f of 2 must be less than 0. Then only, because one is positive, the other one must be negative. Then only the graph meets the x-axis at 3 different points. So what is f of minus 2? F of minus 2 is equals to minus 8 plus 24 plus lambda, that is f of minus 2. And what is f of 2? F of 2 is equals to 8 minus 24 plus lambda is less than 0. Now from this information we can write it as lambda plus 16 into lambda minus 16 less than 0. That means lambda belongs to minus 16 comma plus 16. If lambda values lies in this interval, lambda belongs to this interval, then this equation has 3 distinct real roots, right? For these values of lambda, the given equation has 3 distinct real roots. That is the another question. So next we have 2x cube minus 15x square plus lambda is equals to 0 has only one real root. This has only one real root. For what value of lambda? Come on, same procedure. F dash of x we will find out 6x square minus 30x. I am taking this one as f of x. F dash of x is equal to 6x square minus 30x. Now if you take 6 common, you will get x square minus 30x, sorry 5x. So that we can write as 6 into x minus 5. Same number line, here we are getting 0, 5 plus minus plus. So minus infinity to 0 the function is increasing. Again from 5 to infinity also the function is an increasing function. From 0 to 5, between 0 to 5 the function is a decreasing function, and at x is equals to 0 the local maximum value, local maxima, so that local maximum value is equal to f of 0. At x is equals to 5 we have local minima, so that local minimum value is equals to f of 5. But what is saying in the question, it has 0 and 5. He is saying the function has only one real root. So that's why the graph may be like this. In this case, it is intersecting x-axis at only one point. or the graph may be like this also. These are the two possible cases. Here we have 0 and here we have 5. Here also the graph is intersecting at only one point. Whether you observed or not, local maxima, local minima. This is the local maximum value and this is the local minimum value. Whereas here, local maxima at 0, local minima at 5. That means both local maxima, local minima, here also local maxima and local minima must be of same sign. So this is f of 0 value, f of 5 value. So f of 0 into f of 5. F of 0, that means f of 0 negative, f of 5 also negative. F of 0 positive, f of 5 also positive. That means f of 0 and f of 5 have same signs. That means f of 0 into f of 5 must be greater than 0. Now tell me what is f of 0? F of 0 is equals to lambda. What is f of 5? F of 5 is equals to 250. Right? Because x is equals to 5. 250 minus 25 into 15. 375 plus lambda must be greater than 0. Right? So then we can write lambda into lambda minus 125 must be greater than 0. So for these values of lambda, the function, the equation has exactly one real root. That means lambda belongs to greater than 0 means, you see, suppose separately I show it here, 0 and this is 125 plus minus plus. Greater than 0 means positive. So from minus infinity to 0, union 125 to infinity. For these values of lambda, this equation has exactly one real root, exactly one real root. That means meets the x-axis at only one point. So this is one more question. F closed interval 0, 3 to closed interval 1, 29. The function is defined as f of x is equals to 2x cube minus 15x square plus 36x plus 1. He is asking about this function graph. Next he is asking about whether it is a 1-1 function or not, whether it is an onto function or not. That is the interval given. Okay, f of x is given, find out f dash of x. F dash of x is equals to, domain of the function is from closed interval 0 to 3. We have to check 1, 1 and onto in that interval only, right? So if you say in this interval the function is strictly increasing function, so we can say it is a 1-1 function, right? F dash of x is equal to 6x square minus 30x plus 36. Now if you take 6 common, we will get x square minus 5x plus 6. Now that is equal to 6 into x minus 2 into x minus 3. Now the same information. So 2, 3 plus minus plus. Right? So from minus infinity to 2 and again from 3 to infinity, the function is an increasing function. At the same time, between 2, 3, the function is a decreasing function. At x is equals to 2, we have a local maxima value, and that local maximum value is equals to f of 2. Just for the simplification purpose, I found the value of f of 2 also. That value I got 29. X is equals to 2, substitute there, you will get f of 2 value. At the same time, at x is equal to 3, the function has local minima. So that local minimum value is equals to f of 3. That f of 3, that means x is equal to 3, substitute there. I found that value, f of 3 value we got 28. So based on that information, at the same time you can check what is f of 0 value. f of 0 is equals to 1. f of 0 is 1. f of 2 is equals to 29. f of 3 is equals to 28. Okay, whatever it may be. So we have here 2. At 2 we got 2 comma 29 somewhere here. 2 comma 29. Next here 3. At 3 we have 3 comma 28, because at x is equals to 2 we have a local maximum, at x is equal to 3 we have a local minimum, and f of 0 is equals to 1. This particular point is 0 comma 1. Now the graph we are drawing. Study the graph we got. f of 0 is equals to 1, right? So at 2, local maxima, local minima, both are positive. One information is clear. This has only one real root. That root is also a negative root. That is the information. Now he is asking whether the function is a 1-1 function or not. Check between 0 to 3. You can observe this is the region in the interval 0 to 3. It is a 1-1 function or not. 0 to 3, observe the graph. 0 to 3, observe the graph. Neither increasing nor decreasing. Because you see from 0 to 2, 0 to 2 it is increasing. Again from 2 to 3 it is decreasing. That's why in the entire interval 0 to 3, neither increasing nor decreasing. Otherwise, between 0 to 3, if you draw a horizontal line, cuts the graph at more than 1 point. So it is not a 1-1 function. The function is not a 1-1 function. But now he is talking about between 0 to 3. It is taking all the values or not. Yes, you can check. Between 0 to 3. Between 0 to 3. From 1 to 29. Yes, it is taking all the values. In the interval 0 to 3 you can check. In the 1 to 29. Minimum value is 1. Maximum value is 29. All these values are there in the interval 0 to 3 only. That means for 1 to 29 it is taking all the values in the interval 0 to 3. That means in the interval 0 to 3 we are getting range from 1 to 29. Range is nothing but range is equal to codomain. Whenever range is equal to codomain, then the function is said to be an onto function. Yes, the function is an onto function. Right? So function has one real root, that too negative real root. The other information is not a 1-1 function because it is in the interval 0 to 3. Between 0 to 3, it is not a strictly increasing function, not a strictly decreasing function. That is the reason it is not a 1-1 function. Next, between 0 to 3, it is taking all the values between 1 to 29. It is taking all the values between 1 to 29. 1 to 29, all the values it is taking in the interval 0 to 3. So it is an onto function, right? So that is the way of checking with the help of the graph whether it is a 1-1 function, onto function or not. Next, the question is given like this. F is a function from 1 to 5 to closed interval 0 to 1000. 0 to 1000. A function is defined as f of x is equals to 2x cube plus 3x square plus 6x plus 1. I hope so everyone know this basic information. The quadratic expression ax square plus bx plus c is always positive under the condition a greater than 0 and b square minus 4ac less than 0. Quadratic expression ax square plus bx plus c is always positive under the condition a greater than 0 and b square minus 4ac less than 0. Let's check here. F dash of x, find out. F dash of x is equals to 6x square plus 6x plus 6. Now if you take 6 common, we are getting x square plus x plus 1. Now you can observe here x square coefficient is positive At the same time, b square minus 4ac less than 0. That's why we can say this expression is always greater than 0. F dash of x greater than 0 means f dash of x greater than 0. So we can say function is a strictly increasing function. When the function is a strictly increasing function, no doubt it is a 1-1 function, because it is strictly increasing function. That's why it is a 1-1 function, right? Function is a 1-1 function we got. Now tell me, what is f of 1 value? F of 1 is equals to, a function is an increasing function, right? So somewhere here 1 is there, somewhere here 5 is there. What is f of 1? F of 1 is equals to 2 plus 3 plus 6 plus 1. F of 1 is equals to 12. We are getting f of 1 is equals to 12. So the function graph we are getting like this. It is strictly increasing function. So the graph it is going like this. Now what is the meaning for this? F of 1, this particular point is 1 comma 12. Because 1 comma 12 we got, there is no chance somewhere here I will get 2 comma 0, because it is increasing. Whatever values you will get, these values you will get more than 12 only. But here 0 is there. In the codomain 0 is there. In the codomain 1 is there, 2 is there, 11 is there. For all those values, in the interval between 1 to 5, pre-images does not exist, because it is starting from 12 onwards. We are getting 12 onwards. But between 0 to 11, 0 to 12 open interval, for all those values, there is no pre-image. That's why it is not an onto function. No doubt, because it is strictly increasing function. So it is a 1-1 function between 0 to 1 to 12, less than 12. For less than 12, for all these values, in the interval 1 to 5, no pre-image. That's why it is not an onto function. At the same time, the graph meets the x-axis at only one point. So it is the equation has only one real root. Okay, so that is the discussion regarding. Next class we are going to discuss few applications on this monotonicity and maximum. Okay, bye bye.